Exercise 15.1 from your Ncert book. Question number 6. A teacher wanted to analyze the performance of two sections of students in a mathematics test of 100 marks. Looking at their performances, she found that a few students got under 20 marks and a few got 70 marks or above. So, she decided to group them into intervals of varying sizes as follows: 0 to 20, 20 to 30, 30 to 40, 60 to 70, 70 to 100. Then she formed the following table. So in this tabulated form, we can see that the marks have been marked in ranges or intervals and the number of students have been noted down. So from this we can see that 7 students have got marks between 0 to 20, 10 students have got marks between 20 to 30, again 10 more students have got marks between 30 to 40, 20 students have got marks between 40 to 50, 20 more students have got 50 to 60 marks, 15 students have got marks between 60 to 70, and the remaining 8 students have got 70 and above. When we take the total of the number of students, we can see the total number of students is 90. From this given information, we have to find the probability that the student obtained less than 20% in the mathematics test. When we say less than 20% of 100 marks, here the total marks is given as 100. So 20% of 100 means 20. So obtained less than 20. That means starting from 0 to 20. So we have to look out for this value, 0 to 20 marks, and the number of students here is 7. To solve the sum, first we will write down the total number of students as 90. Now, from the given table, the number of students who obtained less than 20% is 7. From here only we can say. Now, in this case, the event is students obtaining less than 20% marks. Probability of a student obtaining less than 20 marks is equal to, according to the formula, it will be favorable number of conditions by total outcome. So favorable outcomes by total outcome. So the favorable outcomes for this particular event is 7. Therefore, 7 by 90 will be the probability of student obtaining less than 20% marks. In the second part of the question, they have asked us to find out the probability that the student obtained 60 marks or above. Now, from the table we can clearly see that 60 and above, that is 60 to 100. So there is no upper range given, that means the maximum marks, which is 100 marks. So 60 to 100 marks will be the event right here. Now, we can clearly see here from the table that 60 to 70 is one given interval and another one is 70 and above. That means for this particular event, where we have to find out the number of students who obtained marks 60 or above, so in such cases we have to take both the ranges, 60 to 70 and 70 to above. That means 70 to 100. So everybody who are getting more than 60 up to 100 will fall into this particular event. That means the number here are 15 for the range 60 to 70 and 8 for the range 70 to 100. So to solve the equation or the sum, we can write from the given table, number of students who obtained marks 60 or above is equal to number of students in class interval 60 to 70 plus the number of students in the class interval 70 and above. That is equals to 15 plus 8, 23. Therefore, we can say the probability of a student who obtained marks 60 or above is equal to 23 by 90, where 23 is the favorable condition and 90 is the total number of students. For question number 7, to know the opinion of the students about the subject statistics, a survey of 200 students was conducted. So total number of students here is 200. The data is recorded in the following table. So here is the table where we have two columns. One is opinion about statistics, that is either someone likes or dislikes the subject, and the number of students doing so. So we can clearly see that 135 students like statistics and 65 students dislike statistics. So find the probability that a student chosen at random, number 1, likes statistics. Total number of students whose opinion is obtained is equal to 200. That means total number of students is 200. For the first part, number of students who like statistics is 135. Clearly from the table we can write that. Therefore, probability of selecting a student who likes statistics is equal to total number of students who like statistics by total number of students in all. Therefore, we are getting 135 by 200, which can be written as 27 by 40. For the second part, we have to find out the probability that a student chosen at random does not like it. That means does not like the subject. So in such case, we write the number of students who do not like statistics is 35. Clearly, they dislike. Now, probability of selecting a student who does not like statistics is number of students who dislike statistics, that is 65, by total number of students, which is 200. Therefore, we can write 65 by 200 and we can simplify it as 13 by 40. Question number 8. The distance in kilometer of 40 engineers from their residence to their place of work were found as follows. So here are the distances between the residence of the engineers and their workplace. Some have 5 km distance, some has 3 km, somebody has 18 km and so on. Total number of engineers is given as 40. From this table, we have to find out the empirical probability that an engineer lives less than 7 km from her place of work. So this is the first event that we are talking about. So the event here is the engineer lives less than 7 km from her workplace. So let's write down that the total number of engineers is 40 and let us calculate how many engineers lives within 7 km from her workplace. Now we have to keep an eye on the question, that is, here it is said that lives less than 7 km away. So we cannot take 7 km because it is talking about less than 7 km. So we have to skip 7 km from the data while calculating the favorable events. So we'll take 5, 3 and then we have 7. So 7 will not be included because it should be less than 7. Then if we continue, we can see then 2, 3, 5, again 3, 2, 6 and here 6. So be very careful when you calculate it. So we are getting a total of 9 such outcomes. That is the number of favorable outcomes. Now the probability of an engineer who is living less than 7 km from her place of work is equals to number of favorable condition or outcomes by total number of outcomes. So we have 9 by total number of outcomes is 40. So 9 by 40 is the probability here. Next question says that what is the empirical probability that an engineer lives more than or equal to 7 km from her place of work? So what we can see here is more than or equal to. In the previous case we had less than 7. So the things which are not less than 7 are definitely either equal to 7 or more than 7. Again, I am repeating, the things which are not less than 7, they will be either equal to 7 or more than 7. So what we can say is the total number of outcome is 40. Total number of engineers are 40. So the number of engineers who are living less than 7 km from their workplace is 9. So definitely the remaining people or engineers lives equal to 7 km or more than 7 km apart from her workplace. So thus, in this case, we can definitely calculate from here, but we have 40 engineers to work with. Therefore, we can simply subtract this value, 40 minus this particular previous event, which is 9. 40 minus 9 will be 31. So number of engineers living at a distance more than or equal to 7 km from their workplace is 40 minus 9, that is equals to 31. Therefore, the probability of an engineer who is living at a distance more than or equal to 7 km from her workplace is equal to number of favorable outcomes, that is 31, by total number of outcomes, which is 40. The third part says, what is the empirical probability that an engineer lives within half kilometer from her workplace? So if we see the table, none of the values are 0 or none of the values are less than 2. We have 2 kilometers as the least distance from anybody's residence to their workplace. So there is no such data as 0 or half. So hence, within half kilometer from her workplace, there is no such engineer. Hence, the number of engineers living within half kilometer from their workplace is 0. Therefore, the probability of an engineer who is living within half kilometer from her place of work is 0 by 40. Hence, the probability will be 0. Question number 11. 11 bags of wheat flour, each marked 5 kg, actually contained the following weights of flour in kgs. So what we can see here is these are the weights given for which are actual weight of the bags of wheat flour, but they are supposed to be 5 kgs. So we have to find out the probability that any of these bags chosen at random contains more than 5 kg of flour. If we look into this particular data, we can see that one bag has 4.97 kg of flour, another bag has 5.05 kg of flour, another has 5.08 kg of flour, and so on. And 5.00 is actually 5 kgs of flour. That is, this is the perfect weight. But some of the bags have more and some of the bags have less than the marked weight. So let us write down. The total number of bags is 11. So the number of bags having more than 5 kg of flour is equal to how much? So from here we will find out those particular bags which are having more than 5 kgs. That means we cannot include 5 kg as our data. So 5.05 is one such bag, 5.08 is another, 5.03 the third one, 5.06 fourth, 5.08 fifth, 5.05 fourth, sixth, 5.07 seventh, and that's it. So we have a total of 7 bags which are actually weighing more than 5 kgs. So we will not include 5 kg because we are talking about more than 5 kg. Hence, the probability of the bag having more than 5 kg of flour is equal to total number of favorable outcomes, that is 7, by total number of outcomes, which is total number of bags, that is 11. Hence, the probability will be 7 by 11. Question number 12. A study was conducted to find out the concentration of sulfur dioxide in the air in parts per million, that is ppm, of a certain city. The data obtained for 30 days is as follows. So this is the data which has been collected for 30 days, and it represents the concentration of sulfur dioxide in air in ppm. You were asked to prepare a frequency distribution table regarding the concentration of sulfur dioxide in the air in parts per million of a certain city for 30 days. This part was for the statistics chapter. Using this table, find the probability of the concentration of sulfur dioxide in the interval 0.12 to 0.16 on any of these days. So we have to find out the probability of the concentration of sulfur dioxide which belongs to this particular interval, that is 0.12 to 0.16. It is very important to know the value of the interval. That is, when we write a class interval like this in statistics, in such cases, this particular class interval will represent the values so that 0.12 lies in this particular interval, but the upper limit 0.12 is the lower limit and the 0.16 is the upper limit of this particular interval or range. Now, when we talk about an interval, this particular interval will contain the value of the lower limit, that is 0.12, but it will not contain the value of the upper limit, that is 0.16. So in this particular data, if we find 0.12, we will calculate that as one data which lies in this range, but 0.16 does not lie in this range. That means that 0.12 is the lower limit. It will be included in this range or interval, but 0.16, which is the upper limit, will not be included in this particular interval or range. So if we get this particular values, we have to calculate likewise. So since we have to work with this particular interval, let us find out how many such values or outcomes are there in this particular data. So as we can see, the first one is 0.03, which does not lie in this particular range. 0.08, 0.09, 0.04, none of these are lying in this particular range. In the second row, we can see 0.16 is one such data, but as I have just discussed that we cannot include this one as one reading in our interval 0.12 to 0.16 because 0.16 is the upper limit here. So we will not consider this value. We will keep on moving, and still now we have not got any value which is starting from 0.12 to 0.15. Here is 0.12. So we'll calculate this as one such data. Next we have 0.13. Of course, 0.13 lies between 0.12 and 0.16. So this is the second data which is lying in this particular range. If we keep on moving, we can't see any such value yet again. So hence we can say that from this above table, we are getting the total number of days as 30 and the number of days on which the sulfur dioxide concentration is in the interval 0.12 to 0.16 is 2. due to the values 0.12, and another day we have got 0.13. So these two values only lie in this range, and hence the outcome will be 2. Number of days is 2. Therefore, the probability of a day on which sulfur dioxide is in the interval 0.12 to 0.16 is number of favorable outcome by total number of outcome, that is 2 by 30. Hence, we can write it as 1 by 15. Question number 13. The blood groups of 30 students of class 8 are recorded as follows. So these are the blood groups obtained from 30 students. So we have 30 such data here. You were asked to prepare a frequency distribution table regarding the blood groups of 30 students of a class. That was done in the statistics chapter. Use this table to determine the probability that a student of this class selected at random has blood group AB. So from here we will calculate how many students are there who has the blood group AB. So if we start from the beginning, we can see here one student has got the blood group AB. Then if we keep on moving, we can see the second student here has the blood group AB, and we have got one more student, that is the third one, who have the blood group AB. So there are total 3 students who are having the blood group AB. So let us write down. The total number of students is 30, obviously it is given over here, and the number of students having blood group AB is 3. So students having blood group AB is the event, and the number of favorable conditions of this event is 3. Therefore, the probability of a student whose blood group is AB is 3 by total number of students, that is 30. So 3 by 30 is equals to 1 by 10. So hence completed. Thank you everyone for watching. Hope this video was useful. Take care. Bye bye.